guys. So today, 1.2. We've got our IVT. Our extrema. Run out of room. End behavior. And then average rate of change, we always abbreviate as AROC. We're going to start with end behavior because that's the quickest part of this. All right, let's say I give you the function f of x equals x squared. Can you guys visualize that graph? Yeah, okay, what are the ends of the graph doing? Both are going up, right? Okay, what would you have said last year for what the end behavior was doing? Okay, domain is negative infinity to infinity, yes.
X goes to negative and X goes to.
Yes, exactly. So you guys wrote it, don't write this down. This is how you probably wrote it last year, right? As x goes to infinity, either y or f of x goes to infinity. Is that what you guys remember? Okay. We have different notation we got to learn this year. It's saying the same thing, but we're going to use limit notation. So it'll say limit of f of x as x approaches infinity, that goes underneath, is infinity. You might have seen this last year, but I don't think you spent a lot of time. So. And then we can say limit of f of x as x approaches negative infinity, in this case, is also infinity. It's very similar, okay? All right, so let's try another one. So what if I give you, we'll do g of x this time, sorry, mix it up. Let's say negative 5x to the 5th. You guys try that one. Think about what that graph would look like. Remember your end behavior stuff. It's an odd degree. And then try to write the limit notation with this notation for me, okay? All right, guys, talk to your neighbor, compare, do you have the same thing? Check in.
Yeah.
No. Wait, no. No, it's negative. Wait, yeah, that's what I did.
I'm with you. All right, guys, let's look. So first, when it's an odd degree, remember your ends are going opposite directions. And then the fact that it has a negative leading coefficient, this is like the little graph you should be visualizing. Okay, the right side's going down, left side's going up. So our notation, we would say the limit of g of x as x approaches infinity. Did you guys say negative infinity? Okay, and then limit of g of x as x approaches negative infinity is infinity. Okay? Got it on the notation. All right, you will see limit notation over and over this year. As we get further into the calculus stuff, we do a whole skill on limits, so limits will be a common theme. All right, that's it for end behavior. We're moving on to the IVT. So this is called the intermediate value theorem. We shorten that to the IVT. So this theorem is pretty wordy. So let me write it all, and then I promise we'll go back. I'll explain what it's actually saying. Okay, but let's get it written down first. If f of x is a continuous function and a is less than b, and there is a value n such that n is between f of a and f of b, then there exists a c such that a is less than c is less than b, and f of c equals n. Give me a minute here, make sure everybody has it written down. All right, no explanation needed, right? Perfectly clear? Kidding. Yeah, so this is a very wordy theorem. It's not that bad once we break it down into pieces. So the first part, our function has to be a continuous function. Okay, we know what that means, right? Like you wouldn't lift your pencil when you're tracing it. Okay, so I'm going to make a little sketch here to help us visualize all of this. So I'll have some function that I draw here, and it says a is less than b. Those are talking about x values. So I'm going to put a here on the x-axis, and I'm going to put b somewhere over here on the x-axis, right? A is less than b, okay? Then it says there's a value n such that n is between f of a and f of b. All right, f of a and f of b, those are just the y values that correspond to those points, and n is somewhere in between them. So I'm going to draw a little graph here. I'll put an endpoint there, something like that. Would you agree this first point, the ordered pair, would be A, f of A? And the second point, B, f of B? Does that make sense? With me? Okay. So n has to be between f of A and f of B. So n is a y value. All right, so I'm just going to say n is, oh, we'll say it's here on the y-axis. All right, so if this is a continuous function between a and b, you have this y value of n in between those two other y values, then there has to exist a c that falls between a and b such that f of c is n. Okay, so c is back to an x value. It's saying this point basically has to exist, and that's going to be the point c, and then f of c, which falls in the same spot as n. So we've got to have a c somewhere in between. So it's saying if there's kind of like this imaginary line drawn across here at n, it's impossible for the graph to get from this point to this point without crossing that imaginary line if it's a continuous function, right? It could be any y value. Most of what we're going to do is a y value of 0. So we're going to talk about it crossing the x-axis. So if I start with a negative y value and I end with a positive y value, if it's continuous, wouldn't it have to go through 0? That's all this big wordy theorem is telling us, okay? It's saying, well, if we start negative and go positive, we must have crossed 0. Or it's up here and ends down here. As long as it's continuous, you had to go through that y value, okay? All right, we're going to do a problem with this so you can see how it looks, what I expect you to answer with. Let's try one. Any questions before we do one? It's not as complicated as it looks when you're writing it down. It's a lot of words, I know. All right, so let's try one. You are given f of x equals x squared plus 2x minus 3. And you want to know, does f of x equal 0 on the interval -1 to 3? Now you don't have to draw this graph, but you should think about, like, what is this graph? So x squared plus 2x minus 3, like, what kind of graph is that? You guys know? Parabola. Yeah, it's a quadratic, right? X squared. So we know it's parabola. Leading term's positive. We know it's like an upward facing parabola, okay? Is that continuous? Like, is that a nice continuous function? Yes. Okay. That is always step one. You're going to have 5 bullet points in your answer. The first one is always going to be that our function is continuous. So f of x is continuous. If it's not continuous over this interval we're looking at, you can't solve it with the IVT. Like, that is a requirement. It must be a continuous function. Okay? So that's step one. All right, off to the side over here, let's do a little math and figure out, okay, do we think this actually goes from negative to positive or positive to negative where it would have to cross 0. So let's think about it. If I plug the -1 in, so if I find f of -1, what do I get? Yeah, -4, good. Okay, what about if I plug in 3? What do I get for f of 3? Yeah, anybody here? 12, okay. So based on that, do you think f of x is going to equal 0, somewhere in between those? Yes, okay. So now it's just a matter of us stating that in the proper way with the IVT. So first bullet point is done. Second one, we talk about our y values here. So f of -1 is less than 0 is less than f of 3. So I'm going to make a little note to the side of that. This one is y values. And always make sure your inequality makes sense. Like, don't tell me that a positive number is less than 0 is less than a negative number. Like, make sure you put them in the right order so that it actually is a true inequality, okay? All right, our third bullet point. So there exists, and yes, you have to use this wording, okay? A C -1 is less than C is less than 3. So guys, that bullet point, we're talking about x values, okay? Those are your x values. All right, next bullet point, such that f of c equals 0. And then your last one is just by the IVT. So when you're answering these, it's really only the second and third bullet point that are going to change much. Like, you'll have different x and y values. The first one is always f of x is continuous. The last bullet point is always by the IVT. And that fourth one, it's such that f of c equals whatever value we talked about. Most of yours will be 0 though, okay? So just lay it out, bullet point. This is going to be on the free response part of your assessment. So make sure you just lay it out in this format and just give me the info that's needed. So let me have you guys try one to make sure we've got it. So sometimes I give you the info in a function, and sometimes I give you your information just in a table of values. So we'll do one with a table here. So I'm going to give you x, f of x. guys, we want to know, given this table here, does f of x equal 0 on this given interval? And you're told that f of x is continuous. All right, so try this one on your own. Can you do the 5 bullet points for me, okay? And it's okay if you have to look at the other example. All right, guys, check in with someone around you. Compare your papers. I know we got a lot of groups of 3, so everybody talk. You can pick different x values. Like, what did you use? You're not sure? Let me look. Or it obviously happens here, right? And then this is what I was talking about. Right, yeah, you see it. Oh, yes. Yeah, so saying that this is greater than. Yeah, it has to be there. Instead of being the negative oh yeah. No, so it's still into the you can do it in order. Instead of going like this. But you still have the thing, the inequality has to be so I was like, I did this on purpose. Yeah. Well, it's use it a lot more. I got an interest. Still that is good to know. I appreciate that. So, have you ever had this in this situation where it happened? Like, if she's all of a sudden she's like, she has this reaction, it's so funny. So she's that's with her, and now we're she's like,
No. He gave me like
so I will not tell her. But I appreciate that. I'm okay with it.
There's one time I like mixed it over and then I had like extra time, so I was like, okay, I'm going to tell me the next step. I'll get like 2, 3, 4s and like 3.
Did we get bullet point number 1, guys? Okay, that's a gimme, right? Even if you, let's say you get to this question on the test and you're like, I don't know, I can't remember how to do this. Should be able to get that one, right? F of x is continuous. That was given to us. Okay, the second one, there's actually a bunch of different ways we can write it. I'm going to say f of 1 is less than 0 is less than f of negative 3. Okay. If you wrote it the other way, if you said f of negative 3 is greater than 0 is greater than f of 1, that's great. If you picked different x values because you said, oh, well, it clearly happens between negative 1 and 0, you could have written it f of 0 is less than 0 is less than f of negative 1. That's okay too, as long as whatever you're stating there is true. Okay, it's got to have something negative less than something positive. All right. Anybody confused by that? Because I definitely messed with you with the signs on this one. Did it make you think a little? Yeah, we got it though? Okay. All right, so that was our y value part. Now we have to deal with our x values. So there exists a c negative 3 is less than c is less than 1. Now, if you picked the different x values, like if you used negative 1 and 0, those two parts need to match. You can't like suddenly use different x values here than you did in the last one. So we got our y values, we got our x values. Again, make it a true inequality. Negative 3 is less than 1. Okay, we know that. So make sure that's true. Then such that f of c equals 0, because that's what we were talking about. And then end with a gimme by the IVT. All right, how'd we do? We get it? Yes? Lots? Okay. If I said do it without looking at the last one, would have been a little harder, right? Okay, so we'll keep practicing these. I think you do have a couple of them on your math space, but it's definitely going to be a free response type question when we get to your assessment. Okay, so you can write it out, do the 5 bullet points. That's what we're looking for. All right, any questions so far? Okay, I'm going to do a little graph analysis next. Sorry. Okay, we're gonna have, this is where those sticky notes would be handy. Let me draw the whole graph and then I'll give you time to copy it down, okay? And I'll label points for you. All right, I think all the points you need are on there. Give me a second on the graph. So that point on the left, that's -4, -5. Then we've got -1, 2, 1, 2, 5, 4. All right, then over to the side here, I'm going to write out, we're looking for, where is this constant? Increasing, decreasing. Relative max, relative min. All right, so when you're looking at these different intervals for constant, increasing, decreasing, worry about the max and min separately. Those first three, you're going to give me an interval of x values, like it's increasing from here to here, okay? And you always go from the left to the right. So do you guys see a section of the graph that looks constant? Yes, where is it? -1 to 1. And when we're doing this, soft parentheses on both ends, okay? Because at that endpoint, it's not actually increasing, decreasing, or constant. That's like the turning point for where it's changing from one thing to another. So it's constant from -1 to 1. Where would you say it's increasing? You guys can just say it, that's okay. -4 to -1, and is there another spot? 1 to 5, good. So we say parenthesis, -4 to -1, parenthesis, and then union, 1 to 5. Okay, what about decreasing? This one's a little trickier. Yeah. Yep. Good. So starting way on the left is negative infinity to -4. And then again from 5 to infinity. Okay. All right, now relative max, relative min. So your maximums and minimums, there's a few different names that we use here. Absolute max and min means like the absolute highest or absolute lowest a graph can ever go. This graph, because it has arrows on both ends, will not have an absolute max or min, okay? Because infinity and negative infinity, those are not max or min. Relative means within your graph, it's like the top of a hill or the bottom of a valley. Okay, so in that little section, it's the max or the min. Sometimes it's called a local max or min. That means the same thing as relative. Okay, so do you see for maximum, anybody see like the top of a hill? Where would that be? Yeah, over there when x is 5, right? Okay, so the way you write it, what is the maximum? Like how high up does it go? 4, and then where does it occur? At x equals 5. So we would say 4 at x equals 5. If you just list the ordered pair, I'm not going to give you full credit because that's not technically what we're asking for. I know this is telling me the same thing, but in a different way. The maximum needs to be stated specifically as 4, okay? So what do you think you're going to say for the relative min? Good, -5 at x equals -4. And that little middle section here where it's constant, sometimes people want to say, oh, is that a maximum? I mean, it kind of looks like it, but is this point higher than the points next to it? No, because it's constant, right? It stays on the same y level, so that's not actually a maximum. Just like this can't be a minimum. To be a minimum, you have to be lower than the points on either side of you. So this is a minimum. These two are nothing. They're just points. Okay? All right. Questions on that? Yeah.
Can there be multiple maximums?
There can, yeah. So if your graph is something with, you know, you have, well, I could even go the other way again. So you have 2 mins and 2 maxes here, okay? Yeah, good question.
What if the x on the graph is like a constant area?
Then you don't have a max. Yeah, if it was like a weird kind of like goes up, levels out, goes down, and that's it, then there just is no maximum. Or if, I mean, you could say the maximum is 5 or whatever it's at, but it'd be like over multiple x values, so that's a little strange. It's, I'm not gonna ask you that one, okay? Same question.
So all of the turning points are maxes and mins?
Usually, depending on, you know, if anything interesting happens, but just your basic polynomial with the turning points, yes, your maxes and mins will be the turning points. Yep. Okay. All right. Does anyone know what a secant line is from geometry? Anybody remember? Okay, yes, that's tree functions. They are absolutely secant goes with cosine, but yes, the reciprocal. But what about geometry? Like, how many years ago was geometry for you guys? Before you knew anything about any other tricks, anybody remember what a secant line was? Do you remember what a tangent line was? Okay, what's a tangent line?
It touches the shape of one.
Exactly, yes. So here, let me draw a circle. So like, there's a tangent line, right? It touches it in one place. Okay, a secant line crossed your, you usually did them with circles. It crossed your circle in 2 points, okay? For us, on a graph like this, here might be a secant line. Now, obviously, if you extend this, it's going to cross it in more than 2 points. But if we look at this little window of our graph over here, do you see how that blue line touches that section of the graph in 2 points? That's your secant line, okay? So intersects the graph in 2 points. This comes into play when we do our AROC, or our average rate of change, okay? So that's our next section. We're going to do average rate of change. All right, so average rate of change, it's just kind of a fancy way of saying slope. It is technically the slope of the secant line. So we needed to know what a secant line was first. So slope of a secant line. Okay, so let me give you a little graph here. Nothing super precise about it. That's my function. And then I'm going to draw in my secant line here. There's my secant line. And I'm going to label my points. This first one here, I'm going to call it A, F of A. We use a lot of function notation when labeling our points in here. And then this guy will be B, F of B. Okay, think back, way far back, to when you first learned what slope was. What's the formula for slope? Change in y over change in x, yep. Any other way you may have said it. That's perfectly fine. There's just lots of ways to say it. So that's slope-intercept form. That's useful, but not actual, just slope. Yeah.
Is it like x2 minus x1 over y2 minus y?
So close, you have it flipped. But yes, that was the other one I was looking for, was y2 minus y1 over x2 minus x1, right? Like you found your 2 points and you just subtracted your y values, subtracted your x values. That's what we're going to do here. So if I subtract my y values, that's going to be f of b minus f of a over b minus a. Okay, and that's it. That's all average rate of change is finding the slope the way you've always found slope, just with more letters. It's the exact same process. So we'll try one here. All right, so find the average rate of change. We've got f of x equals negative 2x squared plus 4x plus 6 on the interval -3 to -1. Okay, that -3 to -1, the -3 is your A and the -1 is your B. Okay, the endpoints of that interval are the endpoints of the secant line that we're talking about here. So I've got A and B. I need f of A and f of B. So let's find that. So f of A, that's really f of -3. So how do I find that? Yeah, exactly. Plug in -3. So I've got -2 times -3 squared plus 4 times -3 plus 6. What does that equal? And if you need to write out more than that, that's okay. Yeah, what'd you get? For just f of A, for this part? Look again. Anybody else get anything? What'd you get? -24. Good job. Okay. All right, we've got A, we've got B, we've got f of A. What else do we need? F of B, okay. So same process. So f of B is really f of -1. So again, you're just plugging in that -1. Be careful with your signs. That's really the only thing that messes you up here. Yeah, what are we getting? 0 for this one. Good. Okay, so now I'm just going to follow the formula we wrote up there for AROC, f of B minus f of A over B minus A, okay? So AROC is 0 minus -24 over -1 minus -3. That's a whole lot of negatives, but what do we end up with? Just 12, yes. So your average rate of change, your slope of that secant line is 12. Did I lose anybody in there? Okay, questions, guys? That is the end of our notes for today. We good? Yeah, question. Sure. Down here? That one? Or? Oh, okay, sorry. Okay.
You know you have to confuse not only his 2 points. If you see that like on an assignment or a test, we only see like those 2 points. I mean the secant lines are.
Oh, okay. I was like, wait, what? Yeah, so that's just an example of what you're looking at. That's why when I ask you average rate of change, it'll always give you a window like this, like -3 to -1, because it wants you to sort of like just do this and not look at the rest of it. Like, that's it. That's all we're zeroing in on. Forget what else is happening. So you don't have to worry about extending that line, okay? I know that kind of goes against everything you learned in geometry, but yeah. Anything else, guys? Okay, So I am going to make your math space available here in a second, but before I do that, I want you guys to go on to Schoology. I posted a link for the Google form that I normally have you fill out on the first day. You guys didn't have laptops, so go ahead and look at that right now. And while you are doing that, I will get your math space posted, okay?